The front page focuses on the stoichiometry, the coefficients, and the way that a graph can show us those things. This is very different. We're going to read this sentence, or this paragraph, but the key idea here is we are approaching something totally differently with a process called the differential rate law. You don't need to know what that means or even what it's called, but what this does is it takes actual data from multiple experiments in order for us to know what are the factors that do speed up our reaction and what are the factors that don't speed up our reaction. So in this one, we have like chlorine dioxide and the hydroxide ion making a whole bunch of products here. And we have coefficients in different places. It's a 2-to-2 ratio in terms of how quickly they are consumed, but that doesn't mean that it's a 2-to-2 ratio in terms of how much they impact the speed of the reaction. What we're going to get into here and on the next page are called rate laws. It is a law, so it is an equation. We are trying to determine or create an equation that tells me, based upon the amount of chemical 1 that I have, how much can that cause my reaction to speed up or slow down if I were to change that factor? How much does the amount of chemical 2 cause my reaction to speed up, to slow down, or does it not impact that? So a rate law is not just using or comparing our coefficients. It's seeing when I change one of my reactants, how does that cause the rate of reaction to change? And this builds on, but sometimes in a confusing way, seems to contradict collision theory. Because we would think like, oh, more chemicals faster. But what we have found through mechanisms and through experiments is that certain chemicals impact the rate of reaction differently. So these right here are just the step-by-step process. So when I do this certain thing, when I look at these certain experiments, what happens to the rate of my reaction? So we're really breaking that down piece by piece. And our goal is to see, is it a direct relationship or is it an exponential relationship? Or maybe in some cases, there is no relationship at all. And the idea of it potentially being exponential is why it says to the power of, because we are going to create an equation where our chemicals are raised to the power of 1 or of 2 or of 3 or 4 or 5. That's how much changing that chemical changes our overall rate. So we've got some answers that we can check here, but it's really about experimentally discovering how one chemical impacts the overall rate.